Hello everyone, my name is Surya, and in this video I will demonstrate those SOX5 proxy servers that I built for my internship assignment. The first one is custom SOX5 server that I wrote completely using Node.js inbuilt libraries. In this version I handle everything manually, greeting authentication, requesting passing and DNS resolution and tunneling. This shows that I understand how the SOX5 protocol works step by step. The second one is library-based SOX5 server using the Heroku SOX5 package. In this version, the library handles most of protocol details and I just configure authentication and login. This is shorter and easier to use but has less control. In this demo, I will run both servers and show how a client can connect successfully with the correct username and password, and show what happens when the client uses the wrong password. Finally, I will also explain why hard-coded username and password is not secure and what better methods we can use in production. Okay, let's move to the first card. The first card is custom SOX5 server. Okay, shall we move to the first card? First card, and the first card is my own SOX5 implementation, and let me explain its main part. The important nodes net module for TCP sockets and DNS module for domain resolution. I set configuration like host and port and username and password and log level using environmental variables. And I wrote custom login function with levels debugging info, warn and error. It can also print log in JSON format. Okay. The server works in stages. The first stage is greeting. The client says it wants to use SOX5. I check the version and choose username password authentication. And second stage is authentication. In authentication, the client sends username and password and I compare with my configured values. If it is correct, the client can continue. If wrong, the connection losses. And third stage is request, connect request. The client asks to connect to destination host and port. I pass the request, resolve DNS if needed, and then connect to destination server. And fourth stage is tunneling. In a tunneling stage, once connect, I pipe data between the client and the destination. I also count how many bytes are sent and received. This gives me full control the SOX5 protocol and details login for every connection. shall we run first code? We need shell, okay, PowerShell, and sorry, cp stop, and see. SOX 5 proxy demo. Proxy demo. Okay. Shall we move to the without okay, shall we run first code? Are you all ready? Types on user credentials. Just anyway, 10. You can see no success. Okay, shall we open another PowerShell? Yeah, I'm using curl.exe to connect the proxy with the correct username and password. As you can see, the request is successful and the server logs show that a tunnel was open. And shall we test with wrong password and username? Password 1234 and username in turn 1. You can see use rejected by the SOX 5 server. So this first code is my own detailed SOX 5 server implementation. It is longer, but it gives a deep understanding of the control and lets me control every step. Okay, shall we move to the second step? Shall we open new PowerShell and CT SOX 5 Proxy demo. And assignment. Okay. Okay, the second code is much shorter because uses the Heroku SOX v5 library. Here is how it's work. I use .env to load configuration from env file, and I create a server with SOX create server. The library already understanding the SOX 5 protocol, so I don't have the handle creating authentication frame or request passing myself. Inside the server, I just accept the connection and lock the source and destination. For authentication, I use the built-in user password method and check username and password in a small callback function. Finally, I start listening to the host and port. This approach is faster to build and easier to maintain, but it has fewer details and less custom logging compared to my first code. Okay, shall we run the server? In this server, we can run using install. Okay, you can see the server is running. Okay, shall we get another PowerShell? Okay, you can see it's working, and when we use wrong password and username, you can see user was rejected by the SOX 5 server. When we compare the first code and second code, this summarizes the differences. The first code manual implementation, more lines of codes, details, logs and metrics, and full control by protocol handling. The second code use a library and short and easier and less details logging and faster to develop but less flexible. Both works, but they have different purposes. The first is great for learning and customization. The second code is great for quick setup. Finally, I want to mention security. In both codes, the username and password are either hard-coded or stored environmental variables. This is okay for the demo, but it is not secure for real production system. In production, we should never hard-code credentials inside the code. Instead, we should use more secure methods. For example, store secret in secret manager encrypt database. Use time-based one-time password like Google authentication. So the users must provide a 6-digit code that changes every 30 seconds, or use modern authentication system like QWorth or OpenID Connect. This way, if a static password is leaked, the attacker cannot use it without one-time code. This is the end of my demo. I showed two SOX proxy server implementation. Test them with both correct and incorrect credential. Compare the approach and explain why hardcode credentials are not secure. And thank you for watching.